Welcome back to the workshop for one last video on probability density functions. Now, this video just wants to consider a theorem, and we're not even going to look at an example because the theorem itself is just so, I want to say basic and maybe not obvious completely, but once we recognize what's going on, there's really no need for an example. So let's take a look at what's going on here. And be in the calculus mode. Think about calculus as we approach this, and the theorem should become rather obvious. All right, so let's take a look at our notes. If f of x is a probability density function and f of x is a cumulative distribution function, then we have that the probability that our random variable takes on the values between a and b, right? We defined this to be the integral from a to b of the density function, but f of x is also the cumulative distribution function, is also the integral of the density function. Recognizing that, we observe the fundamental theorem of calculus and say that this should be f of b minus f of a, right? It's exactly what we're making use of here. The integral of something is equal to its integral evaluated at the upper limit minus evaluation at the lower limit. And that's all that this is. That's all that is saying. That's it. So this is simply the fundamental theorem of calculus. Excellent. So that's for any constants a and b, but also the density function itself can be expressed as the derivative of the cumulative distribution function, which again, depending on what text you're looking at, may be presented as one large fundamental theorem of calculus, or maybe this one may be presented as the second fundamental theorem. Of calculus, right? Because f is the integral of f. So the derivative of an integral gives you back what you started with, and that's it. Okay, so this theorem is just an expression of the fundamental theorem of calculus and the second fundamental theorem of calculus within the context of our particular situation, probability. I don't think this warrants an example. As long as you're doing as you should, reading along in the text, then you should be absolutely fine. I believe there's an example there. So that's all I wanted to share with you for now. So thank you for your time and attention for this section. I'll see you guys back in the workshop a little bit later when we move on to section 3.5. Have a great day.